everybody, welcome back. We are talking today about polynomials. So first of all, what is a polynomial even? Well, polynomial is really anything where the exponents on the variables are whole numbers, okay? So we could talk about, let's talk about the number system for a minute. The smallest set of numbers are natural numbers, okay? And natural numbers are the counting numbers. So when you ask somebody how old they are, this is probably the answer you're going to get, a natural number. Next we have whole numbers. And whole numbers are 0, 1, 2, 3, etc. Okay? Then the next set of numbers are integers, and they are whole numbers, but they are also whole numbers that are negative. So -2, -1, 0, 1, 2, 3, etc. After that come rational numbers, and we usually call it, we usually call it just Q, meaning quotient. Okay, so they're numbers that can be written as A over B. So A over B, any number that terminates or repeats when divided. So 0.73 with the 3 repeating, 0.5, 0.9628, etc. You get the idea. 0.1333 repeating. These are all rational numbers. Then over here we have non-rational numbers. Okay, and non-rational numbers or irrational numbers are numbers that can't be written as A over B. So they might be, for example, the square root of 2. Okay, that's an irrational number. Pi is irrational. E is irrational. The cube root of 9 is irrational. Okay, any number that you want to take the square root of that isn't a perfect square, or the cube root of a number that is not a perfect cube, the square root of 18. Okay, we could go on all day here. So the natural numbers, or rather the whole numbers, are what the exponents must be in order for something to be a polynomial. Okay, oh, and all of these numbers are what we call real numbers. They're numbers that can be graphed on a number line. There are such things as non-real numbers, they're called imaginary numbers, and they are the square root of -1, essentially, or the square root of any negative number, and we won't talk about that in this video. Okay, so 4x squared then is a polynomial, all right? Because its exponent, the only exponent it has, which is that 2 on that variable x, is a whole number. This is a polynomial. This is a polynomial. Okay, that might look weird. Poly means many. So when we think about polynomials, we think, well, it must mean many terms. Okay, nomial is a number, something that has to do with a number. Poly means, so it means many numbers. So what we're talking about is a many terms. So this has one term, this has two terms, this has one term, and if we take this and we put x to the 0 on it, it becomes clear why we recognize it as a polynomial. So a polynomial doesn't have to be more than one term. Okay, it can be just one term. It can be just a number, as this 5x to the 0 actually is. It's just 5. Okay, so how do we classify them? Well, this is a polynomial. It's degree 1. And the reason it's degree 1 is because we've got an invisible 1, their exponent on that y. This one here is a cubic, okay? It's degree 3 because 3 is the highest power, the highest exponent on those variables. It has 3 terms. So terms are separated from each other by plus signs, minus signs, and equal signs. And we haven't even dealt with equal signs yet in the videos so far. They're coming up soon, okay? This is a polynomial of degree 1. There's an invisible 1 on that. Okay, all numbers have an invisible exponent of 1 on them if you don't see an exponent. Even that 8 does, all right? Again, 7, that's a polynomial. 2x squared minus 8x. This is a polynomial of degree 2. It has 2 terms. So we've done a lot of factoring in the last few videos. If we wanted to factor this, this is not a trinomial, okay? It's not ax squared plus bx plus c. We don't have a plus c. In a situation like this, and again, I've stressed in the past how important it is to always look for what's common first. So common to these 2 terms is 2x. And then if we, so we're dividing 2x out of each term, and what we end up with is x minus 4. Now, what we've got here is, this is 2 terms, this is a single term, okay? These 2 terms, as it were, inside the brackets, there are 2 terms inside the brackets. They're locked together by those brackets, so you can't break them apart. The only way to break them apart is to multiply that 2x through again. But because these 2 things are being multiplied, remember this is a single unit, okay? It's not considered 2 units in terms of this polynomial that we've written. So this is a single unit, this is 2 units or 2 terms. And we have a monomial term here. This is a monomial, and that's because it is a single term, but it's still classified as a polynomial. Okay, and then this here is a binomial. But because these 2 are being multiplied together, we actually have 1 term. Okay, so let's have a look at the classification system of polynomials. So these are called monomials. These are monomials because they're a single term. These are binomials because they are 2 terms, okay? Then these are trinomials because they are 3 terms. But what happens if we have this? This is not a quadnomial, okay? We don't go that far. We just say this is a polynomial. It's got 4 terms. There's no special name or label for a polynomial that's got more than 3 terms. So monomial, binomial, trinomial, and this is simply called a polynomial. However, they are all called polynomials. All right? Okay, now, what do we do with these polynomials? Well, one of the things we have to recognize is when we see or when we have like terms. So let's take some addition of polynomials, and we'll start with something really simple. Now, because everything here is positive, and because there's nothing in front of these brackets and nothing in front of these brackets that has to get multiplied through by the distributive property, these brackets are actually completely meaningless. They have absolutely no effect on our final answer. So I could just drop them, and I would still get the same answer. Now, when you're first learning to add, subtract polynomials, it's helpful to put the terms in order. So we want to put the leading terms, which is the power of 1 on this x up front. And you're not going to do a lot of this because it's really only for when you're learning how to do this that this is useful, okay? Because we could go from here and we could say, well, I can add the 3x and the 5x because they're like terms and get 8x. And I can add the 4 and the 2 and get 6. And I'm done. Okay? Now, again, remember that factoring is very important. We're not going to factor these final products very much, but I do want to point out here that this is factorable. These have a common 2. So if you take out the common 2, you have this. Okay? This is the same as that. I'm going to prove it to you right away. Now, here we've already done the addition, but here maybe it's easier to see them together, and that's why you might choose to write the terms next to each other first. Okay, so what we're doing here is we're simplifying, okay? So a lot of teachers don't bother to really tell you what simplifying actually means. This expression here is the same as this one here. It's the same as that one there, okay? The variable exists because we might want to put different numbers in. So let's say that we have 3x plus 4 as it was written originally, and plus 5x plus 2, and we're going to say x is equal to, I don't know, how about 3, okay? Now, if we put the 3 in for x, here's what that would look like. And we always use brackets when we're multiplying. So the 3 and the x are being multiplied together, and because they are different looking things, different types of things, different elements, we can glom them onto each other instead of putting 3 times x, okay? We know that when they're stuck together like that, that they're being multiplied. So when we put a 3 in, well, we can't just put the 3, can we? We can't put 3, because then it looks like 33. So we need brackets around that. So now we follow our BEDMAS rules. Okay, remember BEDMAS, multiplication comes before addition, so I don't add the 3 and the 4 here, I multiply first. So I get 9 plus 4 plus, I have to multiply these first, I can't add the 5, I have to multiply first. So 15 and then plus 2. And we add there and we get 13, and we add here and we get 17 for a final number of 30. Now, if this expression is the same as this one, or that one, then when I plug in 3, I should get the same answer. So let's use this one here. Okay, so 8x plus 6, or x equals 3. So we're going to put in the 3 for x plus 6. We're going to get 24 there. 8 times 3 plus 6 is 30. Okay? We get the same answer. Of course we do. We have to. It's unless you've made a mistake somewhere, the answer's got to be the same. So this is what simplifying is all about, okay? And of course, the process of simplifying gets a little harder when the questions get a little longer, okay? So we're going to do a couple more here. This is all just beginning polynomial work. So here's one here, 5x plus 7 minus 2x plus 1. Now in the last example we had a plus sign here, and I said that you could go ahead and do the addition leaving the brackets in place. You don't even need to worry about the fact that there's brackets there. Here, not the case, okay? Because of that minus sign, we have to subtract both of these things. So my advice to you always is to take one step extra to take off those brackets. So what you're doing here, there's an invisible negative 1 right there, and you're multiplying that through to those two terms when you get rid of those second set of brackets. So we're going to get minus 2x minus 1. Okay? Now, these two terms are the same, so we're going to do the math with them. 5 minus 2 is 3, and 7 minus 1 is 6. And again, notice that something can be factored even if you're not going to factor it. Okay, if you want to leave the answer like this, that's okay. But notice that it can be factored, because later on when you're doing calculus, you'll thank me for this, trust me. Now, I said that they should be the same, okay? When we finish simplifying, it should be the same expression. So let's make x equal to 2 here, nice and simple, okay? So 3 times 2 plus 2 is 3 times 4, which is 12. So if we put the 2 in here, we should get the same answer. So 5 times 2 plus 7 minus bracket 2 times 2 plus 1. So we can still follow the order of operations. Okay, so we have 10 plus 7 minus, now here we have 4 plus 1. Right? We have to do the multiplication first before we do the addition inside the brackets. And We're going to add those, so we get 5 there, and drop the brackets right away. So 10 plus 7 is 17, minus 5 is 12, and we get the same answer. We have to, or else something's gone wrong, okay? This is always a really good way to check your work when you're learning this stuff to begin with. Okay, and one more example. 2a squared minus 2a minus 7 minus a squared minus 6a minus 11. Ooh, lots of minus signs. Okay, so minus signs are kind of almost a little bit of a little signal. A little flag should pop up when you see a bunch of negative signs or minus signs, because they're a little bit harder to work with. You have to pay attention when you've got them. So, as I said before, because we've got a minus here, if there's a minus there, or if there's any sign and a number in front of the brackets, you want to take one extra step to remove the brackets, okay? So here, we're basically just multiplying in the 1 that's in front of this. So this doesn't even need to be in brackets. It's totally irrelevant. You're going to get the same answer even if it was written without brackets. And then here, we're going to multiply that negative 1 through. So we get that. Now all the signs are going to change inside these brackets, right? Because when you multiply by negative, the sign changes. So negative times negative, that's going to give us a positive there. And the negative times a negative will give us a positive there as well. Now look for things that are the same. So here's another thing you can do. You can circle the like terms. Alright, so a squared we get there because 2 minus 1 is 1. Underline those. Minus 2 plus 6. Minus 2 plus 6 is the same as 6 minus 2. So if it's easier to turn the numbers around because you're uncomfortable with starting with a negative, you can do that. We're going to do lots of number line work down the road. Okay, so 6 minus 2 is 4, and that's a plus. And finally, we have these two, which we can box. 11 minus 7, or negative 7 plus 11 is 4. And if you've been paying attention in the last videos, you might notice that this factors. Okay, so the 4 comes apart into 2 and 2, which adds to make the middle number. We have 2 plus signs to get positive 4. When we multiply two positives, we get a positive, which is what we have here. So because a being this a here, so in ax squared plus bx plus c, okay, because a is equal to 1 here, we go directly to our two brackets. A plus 2 times a plus 2. I've also talked about special quadratics, and this is actually a perfect square trinomial, right? We could factor this and write it like that. So, looking at that quickly, we have a perfect square here and a perfect square here. 1a squared, that's a perfect square. 4 is a perfect square. Square root of 4 is 2, the square root of 1 is 1. Multiply them together, get 2, add it to itself, and that's the middle number. So, because of that, we know we have the perfect square trinomial, and we can go the square root of this term, which is a, plus, because we have a plus sign here. If we had a minus sign there, it would still be a perfect square trinomial, as long as that's a plus. And we would put a minus there in that case. Okay? And then we put the square root of that term, and we put a squared on the outside. There. Okay, so that's a quick introduction to polynomials. Thanks for watching. The next video is going to continue on expansion of polynomials. And they're going to get a lot longer. So tune in, and thanks for watching, and I will see you again. Thank you.